So we've got our very own CEF's head of projects, Andy Yates. He's going to be talking about geothermal delivery for the next 30 minutes. So I'll pass over. Cheers, Andy.
Thank you, Darren. Much appreciated. Okay, good morning, everybody. My name is Andy Yates. I'm the head of projects with the Carbon Energy Fund. I was supposed to be joined today by the Capital Projects Director from the Council of Chester, Ian. Unfortunately, there's a sickness bug going around and his entire department is currently off. So he sends his apologies today, but nevertheless helped me pull the presentation together and is very comfortable and happy for us to talk to you guys today about his site. Okay, so let's talk a little bit about the Countess of Chester site. It is one of our members at the Carbon Energy Fund. And we are working together to bring that whole site to a net zero position. We'll look a little bit more at the carbon curve on the screen in a minute, but essentially we're looking at a 2032 and a 2040 position to be net zero by 2040. The site itself in Chester is ideally positioned for a geothermal asset. We've estimated about 1.5 kilometres, 1,500 metres depth. And the project it does enable, as you can see, the blue line on the graph is actually the performance of the scheme versus the red lines, which are the targets. So pretty much in one hit, we'll be turning off the gas assets for the site, and we will be turning on a net zero asset with, and this is an important part, with no grid extensions or extra requirements. So the electrical requirements for geothermal are a lot less than other green technologies like heat pumps. Okay, so Countess of Chester, it's an acute hospital in Chester. The name gives it away. It's a full range of services, about 65,000 square metres and 625 beds. Those of you with hospitals, you can put that into perspective with your own. It's got a mix of assets at the moment. It's got a mix of some centralised steam boilers, which you can see in the picture, plus 10 other plant rooms, and on total on site there are 33 gas boilers. The site also has a redundant CHP engine, which ran for 15 years and is now end of life. The site has a 2.5 MVA connection in port, and it is being currently extended, but not for the geothermal. It's being extended for a new women and children's facility due to the current one being a rack building. And that facility opened about 2 months ago, so it is now operational. The heat itself, as I said, comes from mostly from the original boiler house in the form of steam. It's one end of the site, and it's in an area of the site that's strategically important to the Trust. So our project will be looking at where to build a new asset as well as replacing it. And in there, just as a few numbers, there are 2 boilers, each rated at just under 3 tonnes an hour of steam production. And the boilers are end of life, they're 34 years old, which is very important because the project itself is funded by a Salix PSDS4 grant. And just some basic numbers there in terms of the heat capacity, the peak one being the heat demand at 5.3 megawatts. And that's what we're aiming for with our new asset. So we dreamt up the scheme because of this little map. And this little map shows areas of the UK where geothermal assets are potential. I'll just emphasise potential. It's not a done deal until you do your viabilities and you drill a hole. But you can see the areas of red being high, orange, medium, and yellow, good. And in essence, it's what temperature the water is at about 1.5 to 2 kilometres under our feet. And you can see from there, Chester is sort of just under Liverpool, and it's in a nice solid yellow area. And incidentally, if you look at other technologies we touched on, heat pumps a minute ago, they would have looking at a COP of about 2. So for every kilowatt of electricity we put into the site, we're getting 2 kilowatts of heat. They may have hydrogen at this site in the future, They're very close to a hydrogen hub at Ellesmere Port. But it is the geothermal asset that we've put forward and been successful with Salix. And we are one of 3 schemes that are successful with that. Dave Smith from UHB was up here a minute ago, they're the other, and the University of York is the 3rd. So we're very proud of being able to deliver this project. And we've done our due diligence, and we know that we are looking at the asset at about 1.5 kilometres, maybe slightly deeper. And here's the interesting bits. We think an operational life of about 40 years. And some of the guys might say more than that, and some of them are nodding and sitting in front of me now. But in essence, a heat pump system might be 15 or 20. So when we look at the lifespan of a project, we've got to look at it over a much longer period, because the capex is higher, but the benefits are also higher. So we talked about a COP of 2 for a heat pump. We are estimating at the moment somewhere between 6 and 10 for the geothermal well. And that's why we're not going to bring in any more electricity to run this site. So for every 1 unit of electricity we put into the geothermal pump, we'll be getting 6 to 10 kilowatts of heat out of the system. So somewhere between 3 and 5 times as efficient as the heat pump. We also have a potential on this site to join it up with its partner who share the site. It's a separate trust, but the well may be able to provide them with energy as well. So here's a quick overview of the site. As I've said, it is, thank you Salix, a PSDS4 successful grant, and it does move us to net zero in 1 step. So there isn't a pathway here, it's literally we turn the geothermal well on, we turn the boilers off, and we are at the net zero position. Our aim is to produce water out of the wells about 55, and then use heat pumps, I know I said they're bad, but heat pumps to lift it from 55 to 80. If we find water hotter than 55, and we don't need the heat pumps, that's where the COP of 10 kicks in. If we need the heat pumps, the COP is 6, and that's why we have that range. And we don't know the answer to that question until we drill the hole. So we've left ourselves on purpose a range. So when we talk about business case, we're talking COP of 6. When we talk about target position, we're talking COP of 10. And if we get the COP of 10, it'll be because we found water at around about 80 degrees below our feet. And that is the ideal scenario, that's what we're aiming for. Part of it though, at the moment the Countess has a steam distribution network. Inefficient, old, end of life. It's being replaced with a low temperature hot water network as part of the scheme. And it goes to all the plant rooms, I won't run through them, but generally speaking on the picture behind us, anything blue is the Countess of Chester. Anything green is the second trust that I mentioned a minute ago, Tush and Wirral partnership. They unfortunately aren't Salix compatible because they've got brand new gas boilers. But it might be something when they are compatible, we'll be able to switch them over to the geothermal well at the same time. And in terms of resilience backup, we are using gas boilers, but they are there for resilience only. For following the HTM on dual fuel. They're not there for any kind of top-up. We're not going to be running them apart from once every 5 years when we have to take the pump out of the well and replace it. And that's just a larger view of it. I've already talked about that. I talked about where the existing energy centre is, which you can see over here, over there, sorry. And we're moving the geothermal energy centre to the other side of the site, and that gives us the location to drill the well. And when we're finished with the well, it'll end up looking like 2 double garages. When we're drilling it, very different. We need to be thinking of a football pitch. So to get the drilling rig and all the stuff you need around it to drill the hole for 6 to 12 months, we need some land to do it. And that is one of the challenges with geothermal schemes. When we're finished, it's just a hole in the ground. And the hole at the top is about 2 feet in diameter. So we're not talking about a big hole here. But to drill it, football pitch. And that's why we've located it where it is. There's an area of land to the top right of that, which is where we're going to be using for drilling potentially, or we're using the car park as the location. So I said we touch on the carbon curve. So the red line represents the NHS target for this site. So you can see where we are at the moment, just over 6,000 tonnes of carbon per annum. It drops in 2032 and then drops to zero at 2040. And you can see that the grey line, the shaded area, is if we did nothing. If we literally said we're not going to do anything on that site at all, that grey line represents the carbon emissions of that site over the life. The blue line represents what we're going to do with the geothermal well. And the only reason it doesn't drop to zero is that we factor in the carbon element of electricity. So as the grid naturally decarbonises over the coming years, with wind and solar and nuclear and all that other great stuff, as that decarbonises, so will the site. They won't have to do anything, they just sit back and watch the carbon factors of electricity reduce, hopefully. But the important bit here is, normally what we'd like to see is the blue line following the red line. Because the further below the red line we are, generally, the more carbon we're saving, but the more operational costs that a trust would have. In this scheme, very different. Because we've got a high coefficient of performance, that COP of between 6 and 10, we're actually showing a positive revenue position for the scheme. So not only are we investing nigh on 28 million from Salix, we're paying for that, but we're also showing a positive revenue over a 15-year contract. If we look at it over 40 years, it's a massive benefit to the trust. So at the 15-year point, we've paid all the capital off. We don't have to do that anymore. But the asset we've bought with that will run for another 25 years. And that's absolutely, when you're looking at your own projects and what you might be thinking on sites, the biggest challenge you're going to have is decarbonising and paying for it at the same time. Because the two really don't like each other. And finding that fine line in the middle is what we, as the CEF, would love to help you with. So what are we actually doing? Well, this is a very basic schematic, I know because I drew it. Effectively what the system is, we are bringing electricity in to run the heat pump and to run the well. If we only have the well, we only need about 300 to 500 kilowatts of electricity. And when I say only, we're producing 6 megawatts of heat from that. And that's where that COP kicks in. So we'll be running the geothermal well. We've aimed for 55 as our worst case scenario. If it is 55, we'll be feeding that into some high efficiency ammonia heat pumps. And those heat pumps will be feeding the site. And you can see on the right hand side, we've got a resilient boiler which provides the load should the geothermal be switched off. And the aim is to run at normal hospital temperatures, 85 flow, 70 return. If we were building a brand new site, we'd want to run it at 55 degrees, so that we wouldn't even need the heat pumps. So anybody lucky enough to be new hospital program, because you're unlucky enough to have a rack building, that's what we're doing with our customers on those buildings at the moment. So where are we at in the progress? We were awarded a PSDS4 grant in March this year. As I said, just under 28 million. The Trust signed and approved the grant offer letter within the 2-week period. And the CEF kicked off a procurement using our framework in April 2025. The bids are in, and I can't talk about them because we're currently in procurement. But we are aiming to select one of our bidders by the end of this month. We are in the final periods of clarifications and due diligence and all those other great procurement words, but we are aiming to appoint a successful bidder at the end of this month. We will then start off with the geothermal feasibility, and this is funded by Salix, and we funded it on purpose as a risk reduction method. So we're going to do a piece of work that probably is going to cost £1 million. And what it will say is, yes, there's water down there at a certain temperature, or it's not. Or it's not at that temperature, it's at this temperature. And we're working together with Salix very closely to look at that viability, that feasibility report, and decide at that point, are we going to press on? Are we going to spend the other 28 million? Or are we going to flip the scheme over and do our standby project, which is actually heat pumps? Now, we don't want to do that, but it's public money. We have to have those risk decision gates when we're looking at a geothermal project. You can't just say, yes, it's down there, here's 28 million, go and do it. It's just too risky looking at it that way. So we have that process. We've done the first stage, which is generally about 50k, roughly. It's a desktop study. It says thumbs up. The next stage is a million. It gives us that surety. Salix say, yes, you've met the conditions of your grant. Get the drill out and drill a hole. And that's where the big money starts to happen. That's when you go from the 1 million to the 15 million investment in the well. Having said that, we'll also be alongside that developing the contract with our preferred bidder to the point where in March next year, the aim is to have a signed contract and start construction in April. Construction will run for approximately 2 years. During that period, the well construction is about 6 to 8 months of that. The biggest time in there is actually de-steaming the site. So I don't know if some of you heard Dave Smith earlier about UHB. The challenges of de-steaming a live hospital site are huge. Don't underestimate them. If you try and do that in December, forget it. So you need a good couple of summers to allow you to do that. On purpose, we've worked with Salix to generate a 3-year scheme. And it's that de-steaming that's half the scheme that takes the time. And then in March 2028, we'll be pulling heat out of the ground and we'll be feeding the site. And then the contract is going to run on this scheme for 22 years. It is a guaranteed performance scheme using the CEF framework contract, and it shows a positive project value over the period. And that includes repaying all of the investment, some of it grant funded by our colleagues at Salix in the front end. So I'll just repeat that. We're paying all the capital back, it's a positive revenue position, and it's net zero. And that's me, guys. Anybody got any questions? The question was, how are we getting the heat out of the network? Thank you. Are we using plates or are we using heat interface units? And we are, in each of the plant rooms that I showed you, I think about 15 or 16 in total. We'll be taking out some gas boilers in some plant rooms and replacing those with plate heat exchangers. Other plant rooms that are already on wet systems, we'll be taking old plate heat exchangers out and replacing them with heat exchangers that are sized and designed for our new solution. So all in total, I don't know the exact number, but it's probably somewhere between 35 and 40 of those units across the whole site. So the question was de-steaming the site, how are we tackling the de-steaming? Are we using point of use? So we're building a brand new energy centre in a different location so that the existing energy centre remains operational throughout the life, because obviously it's a hospital 24/7, etc. And each of the plant rooms have the heat interface unit, and then there'll be a network of pipes that go from the new energy centre to each area that we're going to. There is a sterilisation requirement on site as well. We'll be electrifying that, so instead of steam to steam autoclaves, we'll be installing electric to steam autoclaves. Now obviously that comes with a little bit of an operational hit on that one, but it's all built into the overall project. It's still a net positive position in doing that. So it's a mix of a lot of different technologies, and every hospital is different. You can't say, we'll do it just like we did it on that hospital, because they're all designed to a very different standard. Okay. I think I got the gist of that, which was basically how are we managing the electricity for the geothermal system within the envelope of the site. So we are increasing the site load from 2.5 to 4 MVA. That's actually being done independently from the project. It's already in motion. So one of the things that made us, or helped us be successful with the Salix application was to show how we were going to, where we're going to get the electricity from. We're not sort of going into it blind and saying, yeah, we'll find it from over there somewhere, don't worry about it. So we built that into our application. And I say it's 300 kilowatts, give or take a little bit, compared to the 4 megawatts of load. But what we've also done is factored in that new women and children's building, which is obviously all electric because it's a modern, just built building. There's no gas in there at all. So we have built that into the equation. And our calculations show that we will be within our envelope without having to extend it. Whereas if we went for heat pumps to do the same thing, we'd be looking at probably bringing in a 33 kV, 33,000 volt supply. The cost of that, the trust had already at about 12 million quid, which basically switched the trust off to doing that type of project, because 12 million quid just to bring the wire in. And then what you've got to think about is what's coming down the wire and how much is that going to cost you. Because it isn't just the capex of the cable, it's the current cost of electricity at 20, 25p a kilowatt. That's really going to have a revenue impact. Okay, if there are no more questions, I'd say thank you very much.